Okay, hello everyone. This is the algebra class. This is the blue book. This is the first lesson is lesson 37, and it is using scientific notation. Okay, for the 3 weeks that the three lessons that we'll be doing this week, what you'll find is that I will start at the explaining the new concept. We will go through the new concept and then go through the examples. Okay, example 1, example 2, example 3, example 4, and example 5. And then you'll be in charge of doing the lesson practice. Okay, so let's go back up to the new concept. Alright, today's new concept is scientific notation. Scientific notation is basically used by scientists, by math, upper math, and what it does is you're able to write down very large or very small numbers, basically to save space. Okay, and you'll see that this is done by I'll just show it to you. Okay. First thing is we're going to copy the table. So please pause the video so that you can copy these two tables. Okay? Pause the video so you can copy the two tables. I'll let you do that. Okay, let me select all, edit, cut. Okay. Alright, so I will assume that you've already done that. Alright, and let me show you what this is all about then. Okay, alright, we got off track there. So scientific notation is about writing numbers, okay, that are very large. Alright, so let's just see. Here's the first example. They have 108 times 10 to the second power. Okay, that's in scientific notation. Now, the standard form is what the number normally looks like. Okay, what the number normally looks like. Now, we know that 10 to the second is 100, and if we were to multiply the 1.08 by 100, you would notice that it becomes, you should have gotten 108. Okay. Easy way to do it, one thing you should start to see is you're going to take the decimal, and because it's 10 to the second power, you're going to move that decimal 2 spaces, and that's why we get 108. Okay, let's collect this, edit, cut. Okay, alright, let's do the next one. So we have 1.08 times 10 to the third power. Okay, again, a simple way to think about it is taking this decimal here and moving it how many spaces? 3. 1, 2, 3. Guess what goes here where there's no space? A 0. So your standard form should be 1080. Okay, 1080. All right, 1080. Let me just erase this. Okay, so that's 1.08 times 10 to the third becomes 1080. All right, let's do the next one. Okay. All right, we have 1.08 times 10 to the fourth power. All right, last time we moved it 3 spaces. Well, how many spaces do you think we're going to move it this time? 4. That's exactly right. 1, 2, 3, 4. Okay, that becomes, put zeros in right there for the ones that 10,800. Okay, now let's do the next one? 1.08 times 10 to the 5th power. What do you think is happening here? Yes, we move it 5 spaces. 1, 2, 3, 4, 5. Okay, so that becomes 108,000, 100,000, like so. What happened? Do you see the pattern? Each time we're adding a 0. Okay, each time we're just moving it 1 space over to the right. Okay, so it becomes, it's eventually coming a very big number there. All right, it's good. Okay. So what pattern do you see? Hopefully you're starting to see that we're moving it 1 more space to the right. Now notice these here. Okay, these are negative. These are negative integers there. Okay, remember, a negative integer does not mean a negative number. All right, a negative integer does not mean a negative number. A negative integer just means that it is a very small number. Okay, so let's start with the first one. Okay, we have 1.08, this is a decimal, times 10 to the negative 1. Now before, I don't know if you realize that with the positive we moved it to the right. On these we actually move it to the left. So this becomes, in standard form, this would be 0.108. Okay, what about the next one? 1.08 times 10 to the negative 2. What do you think we're going to do? We're going to move this decimal 2 spaces to the left. Okay, so it becomes 0.0108. Okay, what about 1.08 times 10 to the negative 3rd? Okay, what do you think? 1, 2, 3. Zeros go in that place right there. So it becomes 0.00108. Okay? Alright, so notice with the positive exponent, for example, 10 to the 4th, we moved it to the right, the decimal place to the right 4 spaces. And if it was 10 to the negative 4, we moved it to the left 4 spaces. Okay? So that's the new concept. Alright? Okay, let's look at first example. First example is write 856,000 write it into scientific notation. Okay, so let's edit, select all, edit, cut this. Okay, all right, that's so 856,000. All right, 856,000 is a big number, and even though you don't see the decimal is right here. Okay, every number, if it like 5 or 15, the decimal is at the end. So what we want to do is we want to write that in scientific notation. Well, if you notice, scientific notation is listed so that it has one number in the ones, and the rest are in the decimal side. So we want to move this decimal between the 8 and the 5, so it looks like this. Okay, and we don't need to put those zeros there. Okay, so how many spaces did we move it? We moved it, so you're going to go back and you're going to count 1, 2, 3, 4. Notice I go between the numbers, so 1, 2, oh, I missed one. Shoot. 1, 2, 3, 4, 5. Okay, so I moved it 5 spaces. All right, 5 spaces. So it is times 10 to the 5th. Why is that? Because remember, when I started scientific notation, I move it to the right if it's positive. Okay, all right. So yes, I went to the left, but I started standard notation. Okay, it's a good idea to think in terms of, this is a very large number here, 856,000. 8.56 is obviously smaller, so I had to make it a larger number. That's why it's going to be a positive exponent. Okay. All right. Cut. Okay. And there you go, 8.56 to the 10 to the 5th power. Okay, we'll stop there. All right. Okay, so now let's go to example 2. Example 2 is at the bottom of the page here. Okay, let's take a look. Let's see. Okay. Example 2. Let's not that one. Example 2. This is lesson 37. There it is. Okay. So example 2 is right here, and we are multiplying numbers in scientific notation. Okay. Notice what they did first. All right. They multiplied. If you're multiplying 5.7 times 10 to the times 10 to the 5th. Yeah. Okay, there it is. Times 1.8 times 10 to the 3rd. They grouped up the two numbers together, so 5.7 times 1.8, and then they brought up the tens together, times 10 to the 5th times 10 to the 3rd. You're allowed to use that by using the cumulative and the associative properties. Okay, so what happened then was they went ahead and multiplied 5.7 times 1.8. They got 10.26. And 10 to the 5th times 10 to the 3rd. You would add exponents. That's why it becomes 10 to the 8th. So the answer is 10.26 times 10 to the 8th. But then notice that that is not in scientific notation. Okay, because you have 10.26 times 10 to the 8th. Scientific notation, the decimal place we go here. Remember, in scientific notation, there's only one number in the ones place. So you would have to move it one space. So it would be 1.06 times 10 to the, 10 times 10 to the 9th power, times 10 to the 9th power. All right, and times 10 to the example 2. Times 10 to the 9th power, okay? Okay. Times 10 to the 9th power. All right. We will continue on with example 3 on the next video.